For discussion 13, I'm going to be doing problems 10 and 12 from 15.3e in the textbook, which asks that we determine whether a vector field is conservative, and if it is, find the potential function. So for problem 10, that is not in frame, the vector field given is the field f of xy equals e to the 2x sine of y I plus e to the 2x cosine of y j. So first step in determining whether or not this function, this vector field, is conservative is going to be determining whether or not the partial derivatives of these are equal. We're going to say that this is m and this is n. First, we're going to do the partial derivative of m with respect to y, which is going to be e to the 2x, that stays the same, the cosine of y, because derivative sine of y is just cosine of y. dn dx, our next step, we're going to find the derivative of that. Derivative of e to the 2x is going to be 2e to the 2x times cosine of y. Cosine of y stays the same because we're doing the partial with respect to x. Now, in this case, dm with respect to y of dn with respect to x are not equal. Therefore, f of x comma y is not conservative. Now, the next problem, problem 12, vector field's a little bit longer. F of x, y, try and make that a little bit neater, is equal to 2x cosine of y minus y cosine of x I plus negative x squared, the sine of y minus sine of x j. It's a little bit out of view. There we go. Now again, we're going to say that this is our m and this is our n term. Now, the partial derivative, dm dy, with respect to y, that is going to turn into negative 2x sine of y. Derivative of cosine is negative sine. And minus the cosine of x. That negative y just turns into a negative 1. dn dx is going to be equal to that negative x squared, again, negative 2x, sine of y stays the same, minus sine of x will turn into minus cosine of x. Derivative of sine is cosine. Now, dm dy equals dn dx. Therefore, f is conservative. Problem, of course, asks what is the potential function if the vector field is conservative. So what we're going to do is to find the potential function f of xy that satisfies this. We are going to say that that is going to be equal to the integral of the partial derivative of xy with respect to x dx, which is going to be equal to the integral of m with respect to x. Now, that integral is, of course, just going to be the integral of this top part up here. So integral of 2x is just going to be x squared, 2x squared over 2, which just turns into x squared, times the cosine of y, of course, stays the same, minus y. The integral of cosine is sine of x. So that is our first, and we're going to add in the constant of integration, c1 of y. The potential function is also going to be equal to the integral of f respect to y. The function is partial derivative with respect to y dy, which is going to be equal to the integral of n dy n, which, again, negative x squared stays negative x squared, and this sine of y is going to turn into negative cosine of y times negative cosine of y. We're just going to get rid of both these negatives. They're going to stay the same. And minus sine of x, we're going to add in our y term, sine of x. Of course, negative 1 integral of that turns into just y, plus c2 of x. Again, our constant of integration. Now, what are these constants of integration? We'll rewrite them down here. c1 of y and c2 of x. Now, from our first function, we're going to look at the integral in the second. And we're looking to see if there are any terms that only have y in them, and there are not. So we're going to change this constant of integration to just be k. Now, c2 of x. We're going to look at our first equation. Are there any terms that only have an x value? There are not. So this is also just going to be k. It's very good to be able to know that these are the same. So our new constants of integration are just this. So our potential function, f of x, y, might as well have it straight. It's just going to be either of the partial pieces, cosine of y minus y sine of x, plus our constant of integration, k. And to check this, we can take the partial derivative of x and the partial derivative of y. Partial with respect to x will turn into this m term. With respect to y, will turn into this n term.